For the second component of the problem, that's I, we want to compute again f of x plus h minus f of x divided by h. We want x to be smaller than 0. So in that case, what we're computing is absolute value of x plus h minus the absolute value of x divided by h. Okay. This is the same as if I have this is x is negative plus this. Let me see, this is minus into x plus h minus or plus x divided by h. Because absolute value of x is minus x, so this is what we have here, and then this is what we have here. And so, if you evaluate this further, this is going to give minus x minus h plus x divided by h. And this is nothing but minus h divided by h, which will give me minus 1. So, if we take limit, so the limit as h tends to 0 of f of x plus h minus f of x divided by h, this limit is nothing but minus 1. And that means that f prime of x is exactly minus 1. So you can see now that when x is less than 0, the function absolute value of x is still differentiable, and therefore, the derivative is minus 1. So this is how we compute this derivative. Third one, we need to compute again f of x plus h minus f of x over h. Here now our x is 0. So this is nothing but absolute value of 0 plus h minus absolute value of 0 divided by h, which is exactly the absolute value of h divided by h. Now, here there are two possibilities. H can be bigger than 0 and h can be smaller than 0. So if h is bigger than 0, for h bigger than 0, so what we have here is that this is h divided by h. Whereas, so this is equal to h over h when h is positive, and it is minus h over h when h is less than 0. And so if h is bigger than 0, this is h over h, which is 1. If h is smaller than 0, we have negative h divided by h, which is minus 1. So this is this, and so we can now see that the limit, so we can now see that limit, if you like, as h tends to 0 from the negative, yes, is equal to minus 1. Whereas the limit as h tends to 0 from the positive is equal to 1. Since minus 1 is not equal to 1, we conclude that this limit does not exist. So this is absolute value of h over h. And this is absolute value of h over h. So since this limit is not equal to this, then this limit does not exist. And so this function is not differentiable at the point x equal to 0. So notice here now what the emphasis I was making, that we do not have to be writing limit as h tends to 0 of f of x plus this minus this over h, and then we say it is equal to limit as h tends to 0, absolute value of x plus h minus absolute value of x divided by h. This one is wrong because we do not have this limit at this moment. We don't have this limit for now, so we cannot write this. But we can first simplify what we have in this quotient the way I did here. So be guided by this. What I've just done is what many people popularly call differentiation from the first principle. Okay? And so let's take a look at a more conventional polynomial that people, let's take a look at a polynomial that many students are very familiar with and see how we can use this formula to get the derivative. So if we consider the function, so example number 2, so if we take the function f of x equal, say, 2x squared, or just x squared plus 1. The problem is find the derivative, or f prime, of x. So what to find f prime of x? Please, I want to say that what I call f prime is another notation for dy by dx, as some people can see in many literature, or df by dx, as you like. So they all mean the same. I'm going to write this. So I say find this. Let me include what is popular at this level from the first principle. Okay, so we want to find the derivative of this function with respect to x from the first principle. And then what is it that is the first principle we're looking at? We are simply saying compute solution. It is enough to compute the limit as h tends to 0 of f of x plus h minus f of x divided by h. And this is nothing but computing the limit as delta x tends to 0, f of x plus delta x minus f of x divided by delta x. I wish to also emphasize that this limit is the same as the limit. Okay, so we see what that is. Don't worry. Let's stop here and then we apply. So if I compute this, is the same thing as computing this. I'm going to use this so that the two notations will be familiar to us. So it is either I do this or I do that, so we are doing the same thing. All right.